Mr. Dror Salee, the Enterprise Security Regional Sales Director of Akamai, with a big round of applause.
Thank you. Very happy to be here. My name is Dror Salee. I'm with Akamai. I'm going to talk about modern-day attacks and how to stop them. This is not going to be a very theoretical discussion, rather very practical. It is based on our experience with real life, both seeing attacks and also preventing them. A little bit about myself. I co-founded a company called Guardicore 12 years ago, in 2013. Guardicore was a pioneer in microsegmentation. I joined Akamai Technologies 4 years ago when Akamai acquired Guardicore. Today, the Guardicore product is at the center of Akamai Zero Trust portfolio product. And Akamai is in a good position to discuss modern attacks and how to stop them because Akamai is processing more than 1/3 of the global web traffic. And Akamai is also one of the largest security vendors. So we are in a good position to discuss attacks. And I want to share with you some data about attacks today. This is data collected by Akamai and also by third parties, such as IBM, which presented before me. So the first interesting point is that the average time to recover from a data breach last year was almost half a year. This is a huge damage to the organization. 85% of the companies we surveyed experienced an API-related cyber incidents over the last 12 months. And DDoS, we have seen more than 7.4 trillion DDoS attacks in the APAC region this year. And finally, in the 2 years after the introduction of ChatGPT, the number of phishing attacks increased by more than 4,000%. So this is really a totally changing landscape. And definitely it's becoming harder and harder to stop attacks. And why is that? First of all, it has to do with the attackers. The attackers today are well organized. The attackers are organized crime, also state players, sometimes state players working together with organized crime. They are automated, and they are taking a lot of advantage of AI. They are early adopters of AI. The second reason has to do with us. The attack surface has expanded dramatically. We are using cloud, we have on-premise, using SaaS, we have remote workers since the pandemic, mobile applications. The attack surface has increased, and this gives the attackers many, many more opportunities. And finally, it has become obvious the traditional security approach, which relies on the perimeter, is not enough. It is failing again and again. And when it meets the organized attackers, the result can be very, very bad. Our data and our business process resides in applications. The application stack has become very complex. We have applications running on-premise and in the cloud. We have SaaS, we have third-party applications, supply chain. There are a lot of dependencies, and dependencies generate vulnerabilities. If we look at how we conduct our business, on one side of the business, there are the applications which actually define and drive our business process. On the other side, there are people who are using those applications. And these people are the employees. Our employees are accessing corporate applications to do their job. We have customers sometimes performing digital transactions on a mobile app. We have supply chain partners, which could be updating inventory or providing managed services. And they all access the applications in a very similar way, typically through a DNS service accessing a web service, which has access to the application through some sort of API. Now, each of these phases is a target of the attackers. People are subject to phishing attacks. The DNS service is subject to DDoS attacks and to DNS hijacking. The web services are being attacked by AI-based bots. There's a growing vector of attack on the APIs. And finally, the target of the attacks is typically our applications themselves. This is where the data exists. This is where the business process is running, and this is where ransomware is going to hit us, and this is where data breach will come from. So what is the best method to secure ourselves in such a situation? The method is considered layered security, or security in depth. The idea is that we will protect against each and every attack vector in the best way and the best methods and the best tools that we have. But we have to assume a breach will happen. And we have to be ready for the moment that the breach has happened. And in order to be ready for the moment that the breach has happened, we have to understand the dynamic of a breach. The moment that the breach has happened is usually not where the damage is happening. The damage will only happen, so if you think about a breach, the attacker will typically take control of some employee laptop or some server, web server or other server, and in this case, there will not be critical information and critical business process. So for the attacker to create the damage, he will need lateral movement. He will need to move inside our network and get to where the business process and the data exist. This is a long process, a complicated process, which we can stop. We can stop and we can detect. And this is, the way to do it is with implementing the concept of zero trust. Zero trust was coined by Forrester as a name about a decade ago. Forrester also today is a good source of information about the zero trust concept. Forrester defined the three principles of zero trust, which also echoed in the previous presentation. The first one is that all entities are not trusted by default. The second one is implement least privilege access. Only allow those minimum connections which are really needed for the business. Everything else, don't allow. And the third one is constantly monitor that because the environment is extremely dynamic, keeps changing. And at the heart of implementing zero trust is the concept of micro-segmentation. This is what my company did. This is what Akamai is now providing today. So let's talk about the importance of micro-segmentation. We'll illustrate that with a simple example. Here we see a typical network of a company, an organization, which unfortunately has not yet implemented zero trust. This means that there may be some firewall inside, but the network inside is flat. There is no separation, not enough separation. And now, unfortunately for this company, one of the employees made the wrong decision and clicked the wrong link in a phishing email. And what happened next is the attacker managed to compromise that employee's laptop and then move to the rest of the network, get into the critical servers, get into the backups, exfiltrate the data, and encrypt it. Now, this is something which can take a company out of business. This is this is the worst nightmare that can happen to you. And unfortunately, it happens. Now, let's consider the same situation, the same company, but luckily, they have implemented microsegmentation. What does it mean? It means that they have implemented security policies around each and every workload, every server, every virtual machine, every cloud instance, every container, every OT device, and every employee laptop. And the policy restricts the connection between every two servers to the least privileged access, meaning that by the source, destination, user identity, and even the identity of the process which is initiating the connection and the identity of the process which is receiving the connection on the other side. There is a policy around each and every workload. Now, in this case, the employee still made the wrong decision and pressed the wrong link, and the attacker still managed to compromise his laptop. However, when the attacker tried to move to other servers, he found that there are policies which are blocking him. And if you also have some detection capabilities integrated into the microsegmentation, which we highly recommend that you do, then while the attacker was making all those attempts, we also detected him, we isolated him from the network, and we cleaned the computer. In the end of the day, this company was hit by a ransomware attack, but did not suffer any damage. And this is not a theoretical discussion. We have seen this happen many, many times in reality. We have more than 1,000 customers globally that implemented microsegmentation. Quite a few of them were really hit by one of the famous or notorious ransomware groups. The initial breach happened, but they walked away with no damage. So this is reality. This is not some theory. And we have seen this again and again. But implementing something like this is not a simple task. It's a journey. It's a process. And I want to discuss a little bit how we do this journey. The first step in this journey of microsegmentation is visibility. In a sizable organization, the network is very large and very complex and very dynamic. So there are many visibility gaps, and we cannot secure, we cannot segment what we don't see. So the first step is to be able to see everything, all the servers, all the virtual machines, all the containers, all the cloud instances, all the SaaS access, all the serverless connections, all the employee endpoints, and all the OT devices. Everything has to be seen, otherwise there will be always an opening. So we have to see all those assets and see all the connections between them and put it on one screen, on one tool. Now, this is going to be a very complex view because there's a lot of them. So the next thing is to group them together. We have to put them based on the business logic, which can be the application they belong to, the role that they are performing, but also environment, location, business owner, even a patch level, anything that we can make use of, and then we can actually make sense of this picture. So once we get end-to-end visibility, we want to have application discovery, and we need to have AI tools to enable us to quickly discover which our applications are, and then implement policies which include the user identity, the source, the destination server, as well as process information. This is basically a process that will make us secure, and to achieve it, we need a lot of automation and we need a lot of AI use. Fortunately, AI has become very useful in these cases. And the idea is that we can select a template, and a template can tell us, let's separate a specific application from the network, or it can tell us, let us protect against the common attack vector of ransomware, like common vulnerable ports. And in a single click, we can get all the policies which belong to this template, approve them, and then immediately get those policies working and blocking traffic. So this is roughly how we do the journey. We start this journey right now with quite a few customers here in Korea, and we think it's going to be a very rapidly changing landscape. If you don't have this, you're much more vulnerable. So let's talk a little bit more about the attack vectors. Inside the applications, there's a growing use of AI. AI generates unique threats as well. And we have a growing use of LLMs, both inside the applications and also hosted in public cloud. Here we recommend using a firewall for AI, which will guard both the input and the output of those LLMs, looking for things like prompt injection on the input and sensitive information exfiltration on the output. API attacks are a growing attack vector, and I mentioned earlier that 85% of the companies we surveyed experienced API attacks over 12 months. And the reason is that developers are introducing a lot of APIs. Many cases, every week there's new API, and those APIs sometimes have vulnerabilities. So let's think about how an API attack looks like. The attacker starts, step one is discovery, identify that there is an API. Step two is enumeration, what this API is doing, which protocol is it running, what is the data it is providing, and most importantly, what are the vulnerabilities in this API. Now, step three, there is no step three. This is the most risky part in API attack, because the moment the attacker identified some sort of vulnerability, it's game over. He can use it to exfiltrate data, perform man-in-the-middle attack, or manipulate objects. There is no more opportunity for us to secure. So how do we defend against that? We have to look for the APIs, deploy a tool that will look for them everywhere, on-premise, in the cloud, SaaS, hybrid, everywhere. And we want to discover all the APIs that we have, constantly discover. We want to manage the posture, identify the vulnerabilities, both in the runtime APIs and also pre-production. Whatever we find, we fix. What we cannot fix, we block using integration with tools that you already have in the organization. Web services are being attacked by bots. Not long ago, bots were very easy to distinguish from humans. We could distinguish from a distance that this is a bot. This is no longer the case. Since the introduction of LLMs, bots have become more and more similar to humans. They behave like humans, they move the mouse like humans. It's not easy to distinguish between them. And they are growing very rapidly. We have observed 11 billion AI bots over a period of 2 months just in the APAC region. This is a huge number. Now, not all of these bots are malicious. Some of these bots are doing good things like indexing the internet for search engines, collecting data for training LLMs. But the good bots are only 15% of the bots out there. 85% are malicious. To secure against them, we need a lot of AI. AI is a good tool, actually, to differentiate between AI and a person. So you have to distinguish between humans and people and between good bots and malicious ones. A little bit about DNS service. DNS is critical for the internet. Without DNS, there will be no internet. But DNS is also a major target of attacks, both DDoS attacks, and we see trillions of those every year, and also DNS hijacking. In the case of DNS hijacking, the attacker will hijack your DNS, maybe through social engineering of the DNS domain register, or more commonly exploit some misconfiguration in your DNS server. Unfortunately, we see a lot of those. Then he will modify the MX record, which lead to the email server, which means that all your incoming mail will go to the malicious email server. Or more commonly, modify the DNSA records, which translate from the domain name to the IP, which means that your domain name will actually lead to a malicious website, which will be very useful for the attacker for phishing, fraud, etc. And just this year, we saw a global company which had the typo in their MX record in DNS. Instead of .net, they wrote .ne. NE is the domain name of Niger, a country in West Africa. And it took them 5 years to identify that mistake. So this is very dangerous. To protect against it, you need DNS Posture Manager, which constantly monitors your DNS entries, looking for misconfigurations, looking for abuse. Last point, but not least, is humans. Humans are definitely the weak point in every security system, and they are being targeted by phishing attacks. A phishing attack is basically usually starting with an email, and somebody is getting an email, and it looks very convincing using social engineering, and sending him to a URL which may look legitimate because it's actually not written in English character, but in Cyrillic characters. So it seems totally legitimate in English. And to protect against this, there are many tools: email security, registered business in social media, sender verification, and especially phishing awareness programs for employees and for consumers. However, most likely somebody somewhere will click the wrong email. When he does, he will be redirected to a phishing website, and most likely his credentials will be stolen. The attacker will either use those credentials to escalate an attack, or he will resell them in the dark web and somebody else will escalate the attack. To avoid that, we recommend using a package which includes it's a brand and account protection, which includes both DNS security and also secure enterprise browser, brand monitoring to stop fake websites and social media applications, phishing-resistant MFA, and secure enterprise browser. And then if the credentials were indeed stolen, use account takeover protection. So this is all a package that will protect you against phishing. Finally, one word about the browser. The browser is definitely a key point in protecting humans. 70% of attacks start in a browser, usually in a link in the browser. Almost half of business critical applications today are browser-based. And there is a growing number of browser-based zero-day attacks. To secure against that, we strongly recommend using Secure Enterprise Browser, which will protect us both against external attack vectors, such as malicious extensions and session hijacking, and also from internal attack vectors, such as unauthorized access and privilege escalation. With that, I want to thank you. The message is simple. You need to protect against each and every attack vector, but assume the breach will happen, and the only way to be ready for that is implementing Zero Trust. And we see this happening today in Korea. Korea is moving very fast on the track of implementing Zero Trust, so this is a very exciting time. Thank you.
Thank you, Mr. Salee, for giving us a meaningful keynote today. 다시 한번 귀중한 발표 보내주신 두 분께 뜨거운 박수 보내주시면 감사드리겠습니다. Thank you once again.